You have almost certainly used one of these. Today we look at what it is actually doing underneath, and it is smaller and stranger than it looks. You do not need any background for this. What a language model actually does. You type a question, and a paragraph comes back that reads as if a person wrote it. Underneath, it is not writing a paragraph. It is doing something much smaller, over and over, very fast. First question, what is it actually working on? Whole words, letters, something else? Second question, where does each new word come from? Is it stored somewhere inside, waiting to be found? Third question, how does one guess at a time turn into a whole answer that holds together? One answer covers all three. It works out what comes next. Then it does it again. That is the kind of model sitting behind today's chat assistants, and that is the one we follow. One thing before we open it up, because it is what makes all of this yours. When you chat with one of these, your question does not go in on its own. It is joined with the conversation so far, and usually with some instructions you never see. All of it becomes one long text. The model then writes the reply as the next part of that text, one piece at a time. So we will follow one short sentence, not a whole conversation. This is the whole thing before we open any of it. The first box is everything so far. Right now it holds the words, "The cat sat on." That sentence is the one we follow all the way through. This is the model. Text goes in and it works out what could come next. One piece comes out. Here it is the word mat. Just one piece, not a sentence. Then that piece is added on the end and the whole thing goes round again. 3 boxes and 1 rail. We open each of them and then we watch it run. Start with one sentence. The cat sat on the mat. Before anything else happens, the text is cut into pieces. The model never works on the sentence as one lump. The word that is one piece. And the word mat is one piece. Follow that one. It comes back on every picture in this video. In English, an everyday word is usually one piece. These pieces have a proper name. They are called tokens. We will just call them pieces. Now an unusual word, kaleidoscope. It comes out as 3 pieces. Kale, Edo's, cope. Notice that those are not parts of the meaning. They are just runs of letters that turn up often in ordinary text. This is one system's way of cutting text up, and another system may cut it differently. A piece can also be a single letter or a mark like a comma. How big a piece is depends on how common that run of letters is. The text so far. The cat sat on the. In this example, that is all the text it was given to work from. That goes into the model. Text in, ranking out. It does not hand back one word. It gives a score to every piece it is able to write, and those scores put them in order. And every one of those scores depends on the text that just went in. The 4 that scored highest are drawn out. Only 4 are shown. The real list covers every piece it is able to write. Top of the list, mad. The bar shows how well a piece scored. The numbers beside them are rough, and they are here only as an example. Do not add them up. Floor and rug also fit, and they score lower. Both of them would still make sense. Moon fits the grammar and almost nothing else, and it still gets a score. At this stage, nothing is ruled out. Everything is simply put in order. Then a separate rule picks one of them. That rule is not part of the model. The picture says usually the top one, but not always. Which way it goes depends on the system. Some take the top one every time. Others pick, on purpose, from the ones that scored well. That is why the same question can come back worded differently if you ask it twice. And here is the part people find surprising. Nothing is looked up. There is no table of answers inside the model being read. The text that went in passes through a very large number of small steps. Training set every one of those steps. What comes out at the far end is one fresh score for every piece it could write. So the score is not found. It is worked out. It uses the text you gave it and a huge block of numbers called the weights. We open those in a moment. One honest note about that. This sentence is one you have met before, and so has the model, many times over. That is part of why Matt scores so high. Text that a model has seen very often can come back almost word for word. So nothing is looked up means no table is being read inside the model. It does not mean nothing is ever repeated exactly. The same 3 boxes, and now we know what each one does. Everything so far goes in. The model works out the ranking. That whole last picture in one box. One piece comes out here. The box is empty at the moment because nothing has been chosen yet. Then the piece is added on the end, and the longer text goes round again. Watch this box and the row along the bottom together. We begin with the words you gave it, the. Cat, those 2 pieces are yours, not its. The box at the top is still empty because the model has not chosen anything yet. Now it runs. First trip round the loop and it picks sat. Sat is added to the row. Everything from here along is the model's own work. Second trip. The text going in is 1 piece longer now. It picks on. Third trip and notice nothing new is happening. It is the same 3 boxes every time. The. Fourth trip mad. And this is a big part of why the answer holds together. Every trip, the model reads the text again. That includes the pieces it has just written. So each new piece is scored to fit the ones before it. It is not making 6 separate guesses. Each guess already knows what the earlier ones were. And it stops when it writes a piece that means stop, or the program around it decides it has gone on long enough. 1 piece per trip round the loop. What each new guess is built on is the text so far. That is how the models behind today's chat assistants produce writing. We said the scores come from the weights. This is them, a huge block of numbers. These are what is inside the box we have been calling the model. The weights are the part that training worked out. The model is those numbers plus the machinery that uses them. Where did they come from? Training. The model was shown a huge amount of ordinary text. Over and over it guessed the next piece. Then it compared that guess with the piece that was really there. Then the numbers were changed just a little so the next guess came out closer. Billions of times. That is how it learns to carry on a piece of text. A later stage of training shapes how it answers you. It learns to act like an assistant. Text goes in. The cat sat on. And text comes out 1 piece per pass. 2 more trips round and it has written, the then mad. The left side changes. The right side changes. The block in the middle is the same block every single time. Training worked these out. Running normally leaves them unchanged, while it is answering you. And so nothing you type changes the model itself. Your conversation does not change those numbers. That does not mean it cannot remember you. Systems built around a model can keep notes and hand them back to it, and the numbers still never move. That is a later video. One last honest consequence. It produces text that fits. Nothing in this picture checks a claim against the world, so it can be wrong in exactly the same confident tone it is right in. That is partly why, and only partly. Looking something up is no guarantee of getting it right either. So, a language model works on pieces of text, and it works out what comes next. Text is cut into pieces first, often a whole word, sometimes part of one. For every piece it could add, it works out a score from the weights. Nothing is fetched from a table. It adds the chosen piece on the end and goes round again. That is how the answer gets written. Which leaves one thing unexplained. Everything it produces is text. So how does one of these end up sending an email? That is next.